Yep, so I'm Esther. Hopefully Colin will suddenly appear halfway during the talk. I'm a senior research software engineer at the National Oceanography Centre. Colin has the same job role as me. And we're going to be talking about a data science platform for the National Oceanography Centre and beyond. We don't envisage this being solely for oceanography, although in its first instance, that is what we're aiming at. And so this is a piece of infrastructure work that we've been undertaking at NOC, the National Oceanography Centre, over the last sort of 18 months-ish, and we are carrying on for the foreseeable future. So first of all, why are we building a data science platform? I'm sure many of us have heard comments like this. Really common one for us is, this piece of software worked on my computer, but I can't replicate the stack of dependencies anywhere else. I don't know what I installed. So we have Unix servers, which people access using No Machine, but No Machine is maybe a bit laggy. The resolution isn't great. It's not a very nice way of working. We've had multiple people coming to our team talking about buying a GPU because they would really like easy access to a GPU, but they just want, they want to run one piece of software on it and don't really have sort of a long-term vision for it. So we set out to try and solve some of these problems. And a bit of wider context around this work is that NOC is undergoing a digital transformation at the moment, by which we mean that we are investing in and developing digital skills, digital infrastructure, artificial intelligence and machine learning capabilities, and really working on external partnerships in those areas as well. And we're building this data science platform to underpin that transformation, to make it easier for our researchers to access compute and, crucially, to have a uniform way of accessing different types of compute, so they don't have to go and learn, different job submission systems. They don't have to, get used to the different ways of interacting with all these different computers that we use. We're using this platform to support our training in digital skills, and I will talk more about that later. And it provides a way of easily accessing accelerated hardware, so both for AI, ML, but also just for codes that are designed to run on GPUs. So our initial audience is the 400 researchers at NOC, although we do have visions of this being bigger than that eventually. But that's sort of where we're aiming at the moment. We've been running a test deployment for about a year now. We purposefully have started with really low numbers and gradually tried to rope more and more people in. So we currently have about 100 people registered for this test system. So what is it? What am I even talking about? We're talking about a Jupyter Hub-based platform. So this is access via a web browser. Our users don't need to install anything on their laptop. They just go to a URL. They log in for our test deployment, NOC credentials that they already have. And it's that easy to access. I'm not going to talk through the picture in the top right because I will cover most of the boxes on it in subsequent slides, but feel free to ask questions about any of them if I don't cover it. So one of the big things we're aiming to do is to remove some of the pain around software environments. A lot of our researchers come to us having maybe got into a bit of a mess with creating software environments. And so we've set up a default environment on this platform where when you log in, if you pick the default, you will get the Pangeo stack, which is sort of the popular geoscience libraries and machine learning dependencies, so things like PyTorch, TensorFlow, and Keras. You'll get hopefully most of the Linux utilities you'd want, so Git, for example. Emacs for me. Yeah, hopefully that's enough for most people to just log in and start working. Obviously, some people will want different things, and it is very possible for people to configure their own environments for the platform. We're just trying to sort of cover off the basics for most people. We also prepare other environments for projects, so we set up sort of just specific project environments and workshop environments as well. There's a lot of MATLAB at NOC, more than I expected when I started the job. And so we knew that this was never really going to be a success unless we could get people using MATLAB on the platform. So we've used the NOC license server so that people can have a MATLAB kernel for their Jupyter notebook, but they can also just open up a MATLAB web interface through the platform, which you know, it's very similar to just using like the desktop version of MATLAB, because it's little differences, but very similar. One of the really popular bits of the data science platform is that we put a remote desktop on it. We actually put many remote desktops on it. We weren't really sure what style of remote desktop people would want. This means that people can run graphical Linux applications in their web browser, again, without having to install anything. And we've had really positive feedback about this. It turns out people really did want an alternative to NoMachine. So yeah, they don't have to install like the NoMachine client. They can, you know, swap computers, go to sleep, wake up in the morning, things will still be running. And yeah, it's very popular for people to do like QGIS using this. That's not moving anymore. So where are we deploying it? So I've talked about the fact that we have this test deployment of it running. This is deployed on servers at the National Oceanography Centre in Southampton specifically. So this is a test system. I should be clear, like these are servers that were borrowed from another project that had finished with them. This is not very high spec. Colin will talk about it later, but we are trying to buy some new hardware for this. So yeah, they're not wonderful, but they do have two old GPUs in them. So they have two P100s, which I think are about 8 years old. And we have an almost identical test server set up as well, with just one of the GPUs. We reckon this is enough compute to support like tens of users, depending on what they're up to. We haven't put quotas into place on this system at all. We sort of wanted to see where we would start running into problems. So we've been adding users on request. Like I say, we've now got about 100 on there. And we've mounted our home and group directory so that people can get direct access to their data. We're also deploying it on national computing facilities, specifically Jasmine. So we're deploying it on Jasmine's unmanaged cloud. It doesn't have direct access to data on Jasmine, which is a bit of a disappointment for users, but it has a faster network link for accessing the S3 style object stores than if you were doing it outside Jasmine, so a bit of a bonus. But crucially, it allows us to open our data science platform to people who are external at NOC. So we're authenticating via Jasmine accounts, and we're using the same image to deploy on Jasmine as we deploy on premises, except we've taken out MATLAB because we don't have the license to deploy it on Jasmine. And obviously we're not mounting our own home directories. We're also currently running a trial with a commercial cloud company. We're in quite early stages of doing that, but we're working on deploying the same Docker image there as we do on Jasmine. Obviously, the appeal there is you've got much more scalability. We can play around with testing lots of different hardware options, and it's really useful for like very external people who don't have, they don't have NOC accounts, they don't have Jasmine accounts. We can open it up to pretty much anyone. Specifically, we're looking at maybe running training workshops or like short project workshops on commercial cloud deployments. So how are we using the data science platform, given that it is in this sort of early test state? It's been quite successful as a general compute resource for people, as you would hope. So we've got people using it for image processing, habitat modeling, machine learning, physical modeling. Having that easy access to GPUs has been really popular. Even though they're old, we've still found that they're faster than sort of the free tier of Google Colab, which is, you know, the easy access people were previously going for. And one of the success stories we like to talk about is that we had a couple of researchers who wanted to run an ocean model called Oceanography, which is written in Julia. It's designed for running on GPUs, and they were running it on their laptops, desktops. We were like, oh, you should try running it on our platform, and they saw 100 times speed up, which was very pleasing. Also, just providing that like easy access to multi-core CPU has been very popular. So this is a picture of a temporal waterline algorithm notebook, and with some work from the RSE team around optimization and implementing the parallelization, we took that from 1.5 hours to sort of 3 minutes in order for that to run. The really big difference it's made to like my life and Colin's life probably is around training workshops. So we run a lot of workshops at NOC. We run them sort of monthly. We're using materials from carpentries, and usually we would send out information in advance to people, telling them what software to download, and then they would turn up to the session, and some of them would have downloaded it and be sat there having already done everything and got it installed, and some of them would not. And for some of our larger workshops, we were spending maybe sort of 30 to 60 minutes at the start just trying to get everything installed on everybody's laptops. And now we just give them a URL, and they log in, and we've set everything up in advance, and it's wonderful. Wasn't super successful with the Conda workshop. We probably need to set up our own Conda board mirror to do that. And now I'm going to pass over to Colin to talk about sort of what lessons we've learned and what we're planning to do in the future.
Is the clicker working?
I think I just turned it off when I was finished.
Okay, thank you. So we made our initial deployment in summer of last year, and we've sort of been trying to see how the platform is being used. As Esther sort of alluded to, like when we hit the limits of it with the hardware we've got, was we didn't really have a great feel for like how much our users would actually like push this to its limits. One thing we did learn is also that we couldn't pre-install everything that everyone wanted, but we could get most of it for most of the time, but sometimes there'll be contradictory requirements. And the way around that is to then make it easy for people to install additional stuff. So anyone who wants to can go and install their own Conda environments and install extra packages, or they can pip install things. Sometimes with slight conflict to our base environment. But we also found that giving users too many choices was also a problem. And as Esther alluded to, we offered 4 different desktop environments at the start. And we did some analysis recently and found that I think one person had once used anything but the default one. And maybe people didn't have as strong feelings about Linux desktop environments as we thought they might. So actually just giving users a sensible default, but then letting them configure things themselves is the better way to do it. So in the latest version of our image, there is a shell script that they can run if they want to change the desktop, but if not, they have the default, which I think is LXDE now. We also found it was useful to give users a bit of information about the performance of the system. So we had a couple of cases where people were running really big jobs, usually on a Friday afternoon over the weekend. And we had 2 particular users who both wanted to do this on a particular weekend, and they were clashing with each other. And I think one was actually running the system out of RAM, and the other was just making it go slow for everybody. And we did have a Teams chat where they could kind of coordinate, but we also set up a program called Moonin, where they could monitor the system usage and just compare the CPU and memory graphs and see if someone else was maxing out the system. Because this is a containerized, isolated environment, if you run PS or top, you do not get any information about anyone else's processes. You only see your own processes. So that was our kind of workaround to that. So for our future plans, one thing we haven't done yet is link this to our HPC system. So although we have Dask installed on the data science platform itself, you are limited to the 56 cores that it has, which is not much for some of the big modeling tasks. And we would like to link that through a Dask gateway to our HPC system to get people access to a far bigger sort of pool of computational resources. And that plays nicely with the way a lot, but not all of our users work, that they are using Dask-friendly libraries such as Xarray that should play quite seamlessly with that. Another big issue is around the access to data. We have vast catalogs and holdings of data, some that are well described and with very good metadata, and some which aren't, and some which have completely lost. And we have an ongoing project from our data services group to actually try and improve the cataloging of data and making it really easy for researchers to sort of submit a very lightweight record of where their data is. And the hope with that is that we will then build up a database of where data sets can be found around our system. So that might be on various network drives or various other servers. And what we'd like to have is a widget within Jupyter that lets you search that catalog, and where that data is somehow accessible to that system will sort of provide you seamless or near seamless access to it, so you don't actually have to worry too much about where that data is coming from. We also have a whole bunch of other more traditional compute servers, which are machines that people SSH into and run whatever they want. And those are run Rocky Linux. Our data science platform at the moment is based on an image that is based on Ubuntu Linux, which is more popular on many people's desktops. But we have this huge base of servers that runs Rocky. Also, if you've come from the Jasmine system, that also runs Rocky. Our HPC also runs Rocky. So we had a demand to build Rocky-based images, and we've started offering those as well recently. And we'd like to try and leverage a catalog of loadable modules that we have on those shared Linux systems and on the HPC, because people can also load software through the loadable module system. We've just been doing some brief experimentation around this and sort of have a proof of concept working where we've got MATLAB running this way. Now, despite Jupyter being a great interface for most people, a few of our more sort of power users said they don't want to use Jupyter. They want to use, quite often it's VS Code from their desktops. And the way they do that at the moment is they set up VS Code to SSH into a remote machine. So if they run a piece of code, it actually runs on the remote machine, but they do all the development work on a local copy of VS Code. And what we're trying to do is offer an alternate way of doing that with an SSH interface that actually gets you into one of our containers. We have a few ideas about how to achieve that at the moment, which we're experimenting with. We don't have anything that works well enough yet. And finally, we want to build an examples gallery with a set of example code that comes from basically every project we do. We're aiming to get one example in there, and that these will be well-written, reusable notebooks that anyone who comes on and does something similar can reuse. We had a couple of use cases for that where we were asked to very rapidly do some data analysis around things that were in the headlines of the press at the time, and that required people sort of having code almost ready to go. And if we could have this gallery up and running, then we could make that a bit easier and give people code they need that's ready to run. It also requires having data accessible as well. And as Esther alluded to earlier, we are in the process of trying to buy some new systems. We would like to buy a Kubernetes cluster, and not just for this, but for a number of other projects we have running where we are deploying various web applications. And we'd like it to basically be big enough for the data science platform and all of our sort of web application use cases. We are aiming to get better GPUs. We're currently looking at the NVIDIA L40 as probably the target for that. And we reckon that will give about a 10-fold increase in speed on our P100s and a 3-fold memory improvement. And over time, we gradually want this to replace some of our shared Linux systems. At the moment, people have their favorite server that they log into, and clearly some are more favorite than others, and they're always busier than others. And then people find they're slow or they run out of memory. And we had some problems actually recently where one of them sort of got very I/O bound and just ground to a halt due to too much I/O going on. With this, we intend that they log into a system with a fixed name, and it then distributes them through Kubernetes to a machine that's got the right resources. And currently we have only set this up in our Southampton site. We have a second site in Liverpool. We do not yet have a version of the data science platform in Liverpool. Actually, that's a slight lie. We have a proof of concept one that started last week on a very, very small server. But we'd like to have a system in both sites. We've also considered that maybe this should be on our ships. We operate 2 research ships, and there are quite a few use cases where researchers actually want to analyze data while they're on a research cruise before they get back to shore. This may be slightly negated by the fact that satellite broadband has improved dramatically recently, and we can now have basically real-time high bandwidth comms to our ships, so they can actually access the shore-based system quite reasonably most of the time. So maybe there is still a case for when that is not working reliably. Right, so time for a quick demo. I'm assuming I can use the mouse on this computer. So we've taken our standard image that we produced and made a somewhat cut down version of it that we have placed on GitHub as a My Binder launcher. So if I click on this, I should be able to launch a subset of our system. And hopefully we built this earlier and it is just going to launch in a few seconds. If it has to build from scratch, it takes minutes to launch. So this is a sort of example of the screen that a user gets when they log in. Standard Jupyter screen pretty much, apart from this desktop icon. If you log in at log, you also get a MATLAB and an R icon as well. So I can, for instance, open Python notebook. I could import a few libraries. And let's put one by house in and so aim is in 10, so we'll make 10 random 10 numbers, extend sending range, and then we'll do ELT.plot obey. Hopefully that will plot me a nice basic graph. So very easy, all the dependencies are there. So this will include NumPy, matplotlib, Xarray, and countless other libraries. And we can also launch our Linux desktop. So I click on that. I don't know if that's, it's just cuts off the bottom of the screen. So this is running somewhere in the cloud on Binder. I'm not quite sure where, but it's reasonably speedy. Drag the window around. And let's try running plot, which we put in by default, and let's do plot x squared. I should get a graph coming up. So there's a full Linux system here with software. Normally we install QGIS and quite a few other larger applications with it. Slides. I think
the first one on the left.
the tab or the yeah, okay, cool. One thing we were wondering is what about more interactive graphical software that has sort of need for high frame rates where people might want to interact with data visualizations? And I sort of thought of this one night when we were running up to our Christmas social, and we run an online social because our group is distributed across 2 sites and quite a few of us live along with the office. And I wondered, could we run Doom on the data science platform? And I don't know how many people have seen this, but there is a long-standing tradition of trying to make Doom run on all sorts of devices, including things like LCD screens on printers, and I think someone even made to run on HDMI cable because there's a chip in that cable that was actually powerful enough to run it. And in case anyone is younger, maybe you don't remember Doom. Doom was one of the first 3D shoot 'em up games and has since been open source, so it's readily available on most platforms. Is this going to play the animation? So yes, it can, but the animation is not working. However, I have also got this going. I think we've got a little bit of spare time. There's another binder here, which I launched earlier as well. Hopefully. Screen again. Turn to full screen. Here is Doom running on over the internet from Binder Hub, and that is pretty interactive. That is certainly quite playable. And we also found that network interactive applications work, so we were actually able to have a multiplayer deathmatch at our Christmas social. Now, actually, Doom is perhaps maybe not the sort of typical example. I did try some more sophisticated games. I also tried Tux Kart, which is an open source clone of Mario Kart, and that did not work so well. But Doom seems to work pretty well. So I was actually amazed at how well that performed. I was not expecting that to be as interactive as it was. So if anyone really does want to play Doom over the internet very slowly, you can follow that link that's in the slides to play Doom. So thank you. That's all we had. Is there any questions in the slide?
Thank you so much, Colin and Esther, for the presentation. It was really very good. We have a couple of questions here.
So I think we could just cover the first one.
Yeah. What do you use for the browser-based remote desktop client? And how do you find performance with graphical applications?
Yeah, okay, so that's the second part. The client itself is called Jupyter Remote Desktop, which is actually using WebVNC.
Okay. Our next question is, do your GUI and Jupyter apps have access to persistent network storage? If not, how is sharing data between apps and users handled?
So on our system running at NOC, we do have access to persistent storage. So users access their normal home directories, they have access to other systems. When it comes to running in the cloud, we don't have access to persistent storage, and we're intending that most people will make use of object storage for that, and that the data they will be coming from object storage.
Yeah. Next question is, how are you deploying new or updated version to the various hardware platform you mentioned, server, cloud, Jasmine? Are you handling deployment manually, or have you set up some sort of automatic deployment when new versions are available?
It's somewhat automated in that we can build a new version of that image, we can push it to a container registry, and then the next user who logs in will get that new image for them. On our on-prem server, we also have a set of rules in the system called Salt that rebuild the system there. So we have to rebuild Salt every time we push an update for that.
Thank you. Next question is, what key features of Kubernetes influence the decision to purchase a cluster instead of upgrading on-premises resources?
We do not have sufficient capability within the other on-prem resources to build a Kubernetes cluster that we like. We currently are running VMware for our VMs, and we don't want to run VMware for a new system. So moving to a more open source stack, and there'll probably be some open stack in there, sort of people under Kubernetes, gets us away from the proprietary lock-in within VMware.
Thank you. Okay, next question. Will you be able to attempt a hybrid Kubernetes cluster across your own two sites, or will you look at replicating the environment in Liverpool?
It's initially, we're probably going to just replicate it, but I'd say, can I ask that question again in maybe a year or two? We've actually had some time to experiment a bit more.
Okay. How can it run Doom, and why is it able to render?
You can run it because it's a Linux graphical application. It can run any graphical Linux application. Doom is just rendering to standard X window like any other application that can do was. I mean, I don't know, was that an expectation that it wouldn't meet the frame rate requirements? Or?
Is Jasmine hosting large datasets used by researchers? If so, are those accessible to people experimenting with the public cloud environment?
So Esther mentioned this earlier, that we're on what Jasmine called an unmanaged cloud, which has no sort of direct network access to most of the data sets. Jasmine do offer a large, like a petabyte of object store, and if people put things in there that are externally accessible, including into our system. You could also use something like SSHFS. We have been experimenting with SSHFS mounts, so people can mount directories. and they could therefore mount their Jasmine home directory that way. I've never been a huge fan of using SSHFS, but in this case, the network speed will be fast enough that you probably won't notice the difference.
Next, how are you helping users to define their own Python environments available as notebook kernels?
Maybe not specific to the platform, but we run sort of a regular drop-in help session where we give users help on anything they need, including quite often Conda and Python environments. And as Esther mentioned earlier, we also run regular training, and amongst those is sort of Conda and Python best practices. Yeah. What was the name of it? Yes. This has got a very nice web interface, so lets us sort of browse the Conda feeds and store packages and manage environments. I suppose it reminds me a bit of the Anaconda Navigator on the desktop.
Okay, there is no more questions. So thank you so much for such an insightful presentation. So let's give them a big round of applause for their time, effort, and valuable contribution.
Thank you.